Hello all, welcome back to CodeHub. Today let us solve the LeetCode's daily challenge. The problem is find closest node to given two nodes. You are given a directed graph of n nodes, number from 0 to n minus 1, where each node has at most one outgoing edge. And the graph is represented with a zero indexed array edges of size n, and that edges indicates that there is a directed edge between node I to node edges of I if the edges of I is not minus 1. So you are also given integers two nodes, node 1 and node 2, and we want to return the index of the node that can be reached from both node 1 and node 2 such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. So if there are multiple answers, return the node with the smallest index. If no possible answer, we want to return minus 1. So let us see the example 1 to get a clear understanding, and this is what the edges, this is what the graph looks like once we've created a graph. So the node 1 is 0 and node 2 is 1, and we can reach node 2 with a distance 1 from node 1 and node 0. So the maximum of both the thing is 1 itself. The maximum of 1 comma 1 is 1, so we return the node index 2 because that can be minimized. That is the minimum possible answer. We will see the example 2, it will be clear. And this is the graph that is created, and the node 1 is 0 and node 2 is 2. And can we reach the node 1 from node 0 and node 2? Is this not possible because node 2 does not have a directed edge between node 1? Can we reach node 2 with 0 and node 2? Yes, it is possible. From node 0 we can have a distance of 2, and from node 2 it is having a distance of distance of 0 to come to node 2. And so the maximum of between those two distances are maximum of 2 comma 0, which is 2. So that is the minimum possible answer that we can get, and the index that can be reached is 2, so we return 2. So the explanation is the distance from node 0 to node 2 is 2, and the distance from node 2 to itself is 0. The maximum of those two distances is 2, and it can be proven that we cannot get a node with a smaller maximum distance than 2, so we return 2. So what we can possibly do is to find the minimum distances from reaching from node 1 to all the nodes and node 2 to all the nodes, and once we have the minimum distances we can actually easily calculate if it is reachable. If the node I can be reached by both node 1 and node 2, then we can just take the maximum between those two distances and we can try to minimize the answer. And for that, what we can do is first we can create a graph of size n. Int n is equal to, I will just code the approach soon so that you can get the understanding what I'm just doing. So we can have a vector of int graph of size n. And how we can create a graph? It is said that I is mapped to edges of I. int I equals to 0, I lesser than n, I plus plus. We can actually create a graph if the edges of I is not equals to minus 1, then it is easy to map them. Graph of I dot pushback of edges of I. This is what the question states, and this is how we can create a graph using the edges. So we have done that. Now what we can just do is we can get the distance, get the minimum distances. That how we can do is we can have a function that is going to get the minimum distances. So I'm going to define a function that that is going to return a vector of int distance 1. I will call this function to be get distance from, and the parameters that are passed are graph and the node 1, and also I will pass the n size n also. So I will also have another vector distance 2. Get distance function is called, graph is passed, and node 2 and n. So what does that this function is defined as? This function is going to give the distances that are calculated, that are going to be minimum from node 1 to all the nodes, and this is going to give the distances from node 2 to all the nodes. So we will have two distance vectors, And what we can do is we can traverse all the distance. We can also have a, we can actually have a int answer index to be -1. So we can, let us have answer index to be n initially, and we can also have a minimum distance that is going to keep track. So we can initially have int max. So for int I equals to 0, I lesser than n, I plus plus, I'm going to define the function. Inside the function, the distance vector, I'm going to initialize everything to be int max. If the node cannot be reached, then the distance 1 of I is going to be int max. So if my distance 1 of I is not equals to int max, and distance 2 of I is not equals to int max, then I can possibly reach from node 1 to this I, particular I. So what I'm going to do is I'm going to calculate the maximum is nothing but the distance 1 of I comma the distance 2 of I. So we have calculated the max now. So if my max is going to be lesser than the min distance, then there is one possible answer. So the min distance I'm going to update to be the max. So I have got a minimum distance value, and I also want to keep track of the answer index. Answer index is going to be I. So at the end of the day, if my answer index is going to be equals to n, then I'm going to return -1 because I have no possible answer, else I'm returning this answer index. Or else what we can do is we can just have the answer index to be -1 initially. Yeah, it is very simple, as simple as that. Now our sole purpose is to define this function. This function is pretty easy. We are going to do a BFS traversal, breadth first search. That traversal is mainly used to calculate the minimum distance between the nodes to all the nodes. So this function is going to return a vector of int get distance, this function, and we are going to have a vector int graph. It is an array, and int node and int n as well. And what we can do is we can define the vector int distance of size n, and it is going to be initially int max, and I'm going to have a queue to do the BFS traversal, queue of int q, and I'm also going to have a vector of int visited of size n, and initially it is going to be 0, and we can say visited of node to be visited, and q dot, and we can just push the node to our queue also. And what we can do is while my queue is not empty, we can just do the traversal. How we can just do, we can get the current node is going to be q dot friend, and we can actually pop this node as well. Now we are going to go for all its neighbors, traverse all its neighbors. For auto neighbors in my graph of current node, what I'm going to do is if that neighbor node is not visited yet, if my visited of neighbor is 0, then I'm taking the note of that, so we'll be getting true. If it is not visited, visit that neighbor, and it is true. And what we can actually do is now we can also push that neighbor into our queue, and we can calculate the distance of neighbor to be minimum of the distance of neighbor comma 1 plus distance of the current node. And we have actually missed one thing. We want to say the distance of the node is 0 initially. Distance of node is 0 because the distance between the node to itself is 0. So distance of node is 0 initially, and return the distance vector. And this is how we can just do it. Now let us try to run our code, and this is as simple as that. This function is going to give the minimum distance from node 1 to node all the nodes, and node 2 to all the nodes, and this is going to calculate. This is going to be our main function. We are creating a graph. we are getting two distances, and if the node I is reachable by both nodes, then we will be keeping track of the maximum, and we will be updating the answer index and minimum distance as well. And finally we are going to return the answer index. That is what the question states. So we just submit the code. Great, it gets accepted. So yeah, the time complexity for this solution will be order of v plus e, where v will be the number of vertices and e will be the number of edges, and that edges is going to be almost one edge all the nodes is going to have. So we can just say order of n, and to create a graph this is going to be an order of n, and here also an order of n traversal, and this is going to be a v plus e traversal. So we can say order of v plus e, and space complexity will be an order of n. We are actually using two distance vectors, and also we are actually having a graph as well, so we can say order of n as well. So hope you like the solution, and let me know in the comments if there are any suggestions. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.